Okay, thanks, Dimitri. So this morning I'll be focusing on the building envelope section. So just to place in context the presentation schedule. So we're going over the envelope section, which is the section 6.5 in the MGP manual of COMNET. Just a brief outline here. Just some general approaches that we took when developing this section for the manual is to be flexible. We allow two ways of modeling opaque constructions, either the assembly U factor or specifying individual layers. There is an Appendix D in COMNET which defines the layers that you can use, the insulation layer, the framing layer, and so forth. A second thing, fenestration geometry as well as a door. The geometry is defined relative to the parent surface. So we're assuming here that obviously for a window, for example, the tilt and azimuth are derived from the parent surface, the parent wall. And then finally, one other modeling concept and how it applies to COMNET is that the building descriptors that are specified in COMNET do not specify a fully articulated building model. And by that I mean that the inputs are intended to verify that the building meets requirements either for the federal tax credit or for green building ratings, but it's not the intent of COMNET to cover, to completely specify all the building model inputs that would be needed for any simulation software. So the first subsection is materials, and the way I presented this information, it's try to kind of simplify and put in table format a lot of the material that is in the COMNET. So this information here is derived directly from COMNET. So for the materials, we have the material name, which has to be different than the predefined list of materials. We have density, specific heat, thermal conductivity, and thickness. And the restrictions on the input for your proposed is simply that it's required. It's a required input if you identify a non-standard material. Construction assemblies, we have a few building descriptors here. The assembly name, which is a unique name. The specification method, as I mentioned previously, it's either U factor or layers. And in COMNET, layers are required for mass constructions. It's not good enough to just to have a U factor. The U factor is the U factors are derived from Appendix A of 90.1 2007. Layers is a data structure. So this is meant to describe all of the layers in the assembly, the framing layer, which may or may not include insulation along with the framing, any other insulation layer, and then exterior finish and so forth. And then finally, I highlighted this one because it's something somewhat new. It's not currently in some standards such as Title 24. But we added something called the U factor derating method, and I think the intent there is to account for some derating or devaluation of the insulation due to either improper or incomplete installation. So for this one, the default value we've used is 1.2. So this is a multiplier on the U factor. So if your U factor is 0.1 for a framed wall, you would multiply that by 1.2 to get the value that would actually be used. The baseline we've set for this is 1.0, which is no derating. There is some precedence in this. The the residential standards in Title 24 have a devaluation of insulation, assuming that it's not installed properly. And then there's a credit that you can take called quality installation that requires acceptance testing. So for roofs, you're going to notice that the format of these building descriptors is somewhat similar to each other. So the roofs, walls, and floors have a similar format. So we have the roof name, just the descriptive name, roof type. So this roof type basically is a key into the tables for the baseline. So depending upon your roof type, that sets your criteria for your roof thermal performance, your U factors. So the available options are attic and other, metal building, or insulation entirely above the deck. And the baseline assumes the type of insulation above deck. So that is used for determining your baseline U factor. Roof geometry is a surface, and it's a data structure, and we've left the details of how you actually specify that geometry to be pretty open or flexible, so that they can define, say, a surface tilt or azimuth, and then define coordinates to define that surface. Roof construction. This is a reference, so it references a construction assembly that's already in one of the COMNET tables. So this defines the baseline performance characteristics, such as U factor. And then finally, exterior roof surface properties. This is a data structure which includes age, reflectance, and emittance. And by default, there's an aged reflectance of 0.3 and emittance of 0.9. I have a note that the California is a bit more penalizing. It assumes a lower reflectance if you don't have certification by the Cool Roof Rating Council. To specify other values, you would specify performance data that comes from the age testing from the Cool Roof Rating Council. So this is the baseline I was referring to. So depending upon the applicable standard, whether it's 90.1 2001 for tax credits or 90.1 2007, we have an insulation requirement by climate zone. Those are the ASHRAE climate zones. Thermal performance is described both in terms of insulation or a maximum assembly U factor. So for instance, for non-residential, for the 2001 requirement, in climate zones 1 through 7, almost all of the climates, it requires a minimum insulation level of R15 continuous, which is equivalent to maximum assembly of 0.063. Similarly, we have requirements for residential and semi-heated. For exterior walls, we have similar types of building descriptors. The name of the wall, which is descriptive, the wall type, and here we have a few different categories. We have mass wall, metal building, metal framed, and then wood framed and other. So the baseline assumes a metal frame type, so that that baseline metal framed wall specification ties in with the table as a lookup value for the baseline criteria for the wall. For the wall geometry, this is a surface. It's a data structure. How you can actually define the wall is left up to the software implementation. For this one, the baseline is the same as the proposed. So you have the same wall geometry. Construction of the wall, again, this is a reference and references a construction assembly that's in one of the tables in the COMNET appendix, and then it's derived from the metal framed wall criteria. Finally, there's an exterior wall surface properties similar to the roof surface properties, but this in addition to reflectance and emittance, also includes roughness. There's a default value, which is used as a default for the input restrictions. Again, this is just a partial version of one of the COMNET tables. It's not, when I cut and paste, the numbering got reset to 1. This is not table 1, the COMNET manual, but it's one of the tables in the COMNET manual, and it just shows the partial definition of some of the construction assembly. So for instance, if you have a wall with R13 cavity insulation plus R18 continuous, it shows the definition of the specific layers and their properties that are used to achieve that particular assembly. So there's a number of assemblies defined in COMNET for this, and then it shows the resulting the resulting U factor. So for the top assembly there, it's a U factor of 0.037 here. Exterior floors, again, we have the floor name, the type, the geometry, and the floor construction. So the floor type options are mass floor, metal joist, wood frames, and other, and metal joist is used for the baseline, so that sets the U factor criteria for the baseline by climate zone. And then similarly, the floor geometry is defined, and then the baseline is the same as proposed. And then the floor construction also, like the wall, references a specific construction assembly. For doors, we have a door name, the type, which is either swinging or non-swinging. The swinging doors have different U factor criteria than the non-swinging doors. The door geometry is a surface data structure. The azimuth and the tilt are defined by the parent surface, which would be the wall. And then the door geometry is also the same as the proposed. The door U factor, there's default values that are used by default for the input restrictions for the proposed building from Appendix A of Standard 90.1 2007 or by NFRC tests. The criteria for the swinging and non-swinging doors are shown here. So we have criteria for the non-residential as well as residential and semi-heated spaces. Criteria are also shown here for ASHRAE Standard 90.1 2007, which is used for green building ratings. For fenestration, this is where it gets a bit more complicated. So this covers both vertical fenestration as well as skylights. For fenestration, we have the fenestration name, which is just the descriptor, and then we have the type. For vertical, we have different criteria for the type, or different lists of options for green building ratings, which is the 2007 standard, than we do for 2001, which was just allowed either a choice of fixed or operable. For 2007, we have non-metal, metal, which could be either a curtain wall or entrance door, or other metal types of fenestration. So the type is set to match whatever the proposed design is. It will be the same for the baseline building. And then for skylights, we have glass with curb, plastic with curb, or skylights with no curb. For fenestration geometry, this is the opening of the fenestration for each window, and the position information is required when modeling exterior shading, so you can get the correct modeling effects when there's shading on the window. And for here, the baseline in many cases will just match the proposed design, but there's a limit on both the window wall ratio, that's the WWR, or the skylight to roof ratio. So when either of those exceeds this limit, the 40% limit for windows or 5% limit for skylights, the windows or skylights, those areas for the baseline are adjusted down in proportion so that the resulting window wall ratio for the baseline does not exceed 40%. And the same can be said about the skylights. But the point I made earlier on this is that we just define what the baseline should be. More on fenestration, so we have the construction. So for the thermal performance, we essentially specify only the U factor, the solar heat gain coefficient, and the visible transmittance. So they're taken either from NFRC ratings or from default values listed in Appendix A. The baseline rules, those performance data are set by climate zone, product type, and window wall ratio. And there's a table in the COMNET manual that specifies these criteria. Two more things. We have external shading devices and internal shading devices. So external shading devices here means things such as overhangs, setbacks by the windows, or self-shading from the building. So if the building itself is providing some kind of shading of some of the fenestration due to its geometry. So the baseline assumes no external shading, and then for the proposed building, there's no restrictions. But of course, like any of these that don't have restrictions, the intent is that it's going to be modeled as the building is designed on the construction documents. For internal shading devices, this is a list data structure. We don't model these for the baseline, and then for the proposed building, for your building, you're not to model them unless they're automatically controlled. So fenestration, this is just another excerpt from one of the tables, a partial excerpt, shows the requirements for U factor, solar heat gain coefficient, and visible transmittance. For skylights, the criteria vary somewhat based on your skylight to roof ratio. What is the area of the skylight relative to the gross roof area? So that affects the skylights as well as the climate zone. So for the skylights, we have the U factor, the solar heat gain coefficient, and visible transmittance. Below grade walls is, let me check the time. Okay, below grade walls, so we have similar building descriptors, the name, the below grade wall geometry, and construction. So this construction assembly, the last building descriptor, the baseline is selected from a table based on climate zone and your building type. So here you have a minimum insulation requirement as well as the C factor for the below grade wall. Slab on grade, there's a few similar building descriptors. We have the floor type, which is either heated or unheated. The slab floor geometry, there's no restrictions in that as well. And then for the construction, the format of this data item depends upon how it is modeled, whether it's modeled with an F factor or whether it's modeled with separate perimeter and interior sections and looking at the heat transfer from each of those sections separately. There's a special algorithm that was developed for Title 24, which models the effects of the perimeter heat loss separately from the interior. So this is if you're modeling the heat transfer from the slab on grade to the earth with just an F factor. It specifies what insulation is required and what that F factor should be for the different climate zones and space types. And then finally, the heat transfer between the thermal blocks. We have a partition name, geometry, and construction. The baseline construction is a steel framed wall with a 5/8 inch of gypsum on each side, so that defines the heat transfer that may occur between thermal blocks through interior walls. There's an Appendix D in the COMNET, which lists the default construction materials. So if you use the layers method to specify a construction assembly that's an opaque assembly, you can build your wall assembly, for instance, or floor or roof using these materials. So the R value, thickness, and specific heat, etc., is specified for each of these materials. So this is in the COMNET Modeling Guidelines and Procedures Manual, Appendix D. So that concludes my overview of the envelope section, and I'd be happy to entertain any questions you might have at this time.